Okay, guys, so today we're going to be learning about the transformations of absolute values. And the essential question is, how does transformations affect an absolute value function? So the absolute value function is an equation that creates kind of a v. And so we know the absolute value of a number is the distance it is away from zero. And so in an absolute value function, all of the points are evenly spaced away from the center, or the vertex, which is what we're going to call zero. So in this lesson, all we're going to be doing is examining what the transformations are. So every letter, notice I have A, H, and K, every letter in this absolute value function represents some sort of change. So A, for example, is going to represent a vertical stretch. If A is bigger than 1, and a vertical shrink if A is less than 1, okay? Likewise, it is also going to be a reflection. If A is equal to a negative number, then it is a reflection. Okay? So A is going to be stretching it, either making it bigger or smaller. H means something different. So if you have an H value, this is where the equation is either, if you have, so for example, if you have minus H, then you are going to shift right. If you have plus H, then you're going to shift left. Okay? And then finally, K is going to be shifting it up if you have plus K. And then if you have minus K, it's going to shift down. So really in this lesson, we're just going to try to memorize what the transformations are and what they mean. Okay? So in this first example, I'm going to identify the transformations of the given function. So I'm really just looking and I'm saying, what does each number mean? So I have a 2. And 2 represents A, so that means it's going to be a vertical stretch of 2. As I go down, it looks like I have an H value. Remember, H shifts it left or right. This is a -1. Minus H means I'm shifting right 1 unit. Okay, and those are all of the transformations that are happening in that equation. Moving on to the next one. I have 1/3 absolute value of x minus 4. The 1/3 is an A value. So because 1/3 is less than 1, that's going to be a vertical shrink. So we're going to just write that vertical shrink of 1/3. And I don't have an H value, but I have a K value. Remember, K shifts it up or down. This is minus K, so it's going to shift down 4 units. Okay. Next one, I have g of x is equal to negative absolute value of x plus 3 plus 2. Now the negative is actually an A value, because remember, whenever I have a negative next to an x, right, it's a -1, it's a coefficient. So this is actually going to be reflection. The 1 doesn't change it, the negative does. So reflection, it's actually going to be over the x-axis. It flips it upside down. Okay, that's what the negative represents. Now the plus 3 is an H value, and remember, H shifts it left or right. Because it's plus 3, it's going to shift it left 3. And then the plus 2 is a K value, which means it's going to shift up. So you can see identifying the transformations is pretty easy when we know what we're looking for, right? I'm always looking at what my A, H, and K are. So last one, I have 4/3 x plus 1 minus 32. So again, I got three things happening. The 4/3 is an A value, and so sometimes what we get confused on is we think 4/3, well, that's got to be less than 1. Well, if you think 4/3 as a fraction is 1 1/3, so that's actually bigger than 1, which means this is going to be a vertical stretch. So vertical stretch of 4/3. Moving down the line, I have plus 1. Remember, plus 1 is an H value, which means it's going to be shifting left. So shift left 1 unit. And then finally, I have minus 32. Minus 32 is in the K spot, so I'm shifting down 32 units. Okay. So now we're going to go into writing a vertical function, write a function given the description. So here I have a vertical stretch of 3 and I'm shifted down 2 units. So what I like to do when I'm doing these is I actually like to write the bones of the absolute value. So I know I have f of x equals blank x minus blank plus blank. So that's kind of like my sentence frame. So I need to find out if I have an A, an H, and a K. So first thing is a vertical stretch of 3. Vertical stretch of 3 represents my A value. So I'm going to put a 3, I'm just going to say right here, A equals 3. I also know that I'm shifted down 2 units, right? Now shifting down, that's a K value. And because I'm going down, it's going to be negative 2. So if I put those numbers in the right spot, I have 3, and I have a K, which is negative 2. Notice how I don't have anything happening here. I'm going to put a 0 in that place. Now, H and K I'm going to put zeros for, but if I don't have an A, I'm going to put a 1. So that's the only thing that's different. So let's make a note of that. No H or K. Replace with 0. No A equals 1. Okay? Actually, we'll put an arrow. So here, this is, so for my equation, 3 absolute value of x minus 0 plus negative 2. Now this is good so far, but it's not simplified, right? I don't need to write minus 0, and plus negative 2 just looks weird. So my final equation, simplified, is going to be f of x equals 3 absolute value of x minus 2. And this represents a vertical stretch of 3 shifted down 2 units for the absolute value function. Okay, now we're going to do the same thing with a different equation, and this time we're doing the horizontal shift 4 units and up 8 units. So f of x equals blank x minus blank plus blank. Okay, so now I have that I am shifting right 4 units. Right, 4 units is an H value. So H is going to be x minus 4, going to the right. So I'm going to go ahead and put a 4 here. And then I'm shifting up 8 units. Okay, so if I'm shifting up 8 units, then that is a K value. So K is plus 8. I have no A value, so remember I'm going to just put a 1 in that placeholder. Now, if I have a 1 in that placeholder, that doesn't change anything. Notice that if I put a 1 here, that would change it, because that'd mean a shift left or right. correct? And if I had a 1 up here, that means it's shift up and down. But 1 here doesn't change it. And the reason why 1 doesn't change it is because I'm multiplying by 1. That doesn't change the equation if you multiply by 1. So my final equation is going to be f of x equals absolute value of x minus 4 plus 8. That's what it is simplified. Okay. Next one, I have a vertical compression of 1/3 and it's reflected over the x-axis. So f of x equals blank, absolute value of x minus blank plus blank. Notice that the 1/3 is a vertical compression that represents an a value. Now it's also reflected over the x-axis. So remember, if a was a negative number all the way up there, then it is a reflection. So this means that our a has to be negative 1/3. And that's actually the only thing that's happening to this equation is I have that negative 1/3 there. I don't have a horizontal shift and I don't have a vertical shift. So there's no h and there's no k. So my equation is just going to be f of x equals negative 1/3 absolute value of x. Okay. All right, last one. We have a reflection over the x-axis and a horizontal shift to the left 12 units. So reflection over x-axis, that is my a value. So a is negative 1, right? There's no stretch, so it's just gonna be negative 1. And then horizontal shift, that's my h value. H is equal to, it's going to look like h plus 12 because it's going to the left. And if I remember up here, right, going to the left is a plus h, or sorry, plus 12, x plus 12 is what it's going to look like. Let's change that so it actually looks like an x, huh? So now let's go ahead and let's write our equation. I'll try to fix it so you can actually see it. If I'm writing my equation, my bones are f of x equals blank absolute value of x minus blank plus blank. Now thinking about the numbers that I'm going to put in there, a is negative 1. Remember, I do have an h. My h is going to the left 12, so I'm going to actually change that to a plus sign. And then I'm not going up or down. So simplifying this, I don't need to put negative 1, right? I just can need to put the negative symbol. So f of x is equal to negative absolute value of x plus 12 and absolute value, because no plus 0. All right, and that is how we're going to be identifying transformations and writing equations for transformations.